Aspirin synthesis from salicylic acid. For this experiment, we are performing the non-microwave procedure. We start by weighing out 0.2 grams of salicylic acid and place it in a 5 ml conical vial. Make sure that the vial is dry. Make sure the triangular magnetic spin vane is sitting properly at the bottom of the conical vial. And then we add 0.48 milliliters of acetic anhydride with the help of a micropipette. After this, we continue by adding 1 drop of phosphoric acid into the conical vial that contains our mixture. And then connect your condenser on your conical vial. Make sure there is an O-ring between this connection. While you're preparing your hot plate to start the reaction, make sure you let this conical vial sit in a beaker so that it does not tip over. Once your hot water bath is ready and around 50 degrees, place your conical vial into your hot water bath. Make sure to clamp it to a stand so that it does not tip over into the hot water bath. Make sure no water goes into the system. Heat and stir your reaction for 10 minutes. After 10 minutes, remove it from the hot water bath and allow it to cool to room temperature in a beaker so that it does not tip over. After it has cooled to room temperature, take off the air condenser and with the help of a clean forceps, take out the conical spin vane. The crystallization should begin. If instead of white crystals forming, you see a color change, your reaction may have impurities and may not have occurred like it should have. You may want to start over. If the crystallization does not begin, you can use a glass rod to scratch the edges of the walls to induce crystallization. In the end, you should see white crystals. And then move on to put your conical vial into an ice bath. Along with your conical vial, put some amount of distilled water into a graduated cylinder and place it into an ice bath to have cold water. And then add 3 milliliters of cold water into your vial and stir thoroughly. Proceed to collect your white solid by vacuum filtration. The filtration setup is prepared as was done in the previous experiments. Make sure to clamp it to a stand. You may want to wash your conical vial with ice-cold water a few times, with an extra of 1 milliliter ice-cold water to collect all the crystals remaining in the conical vial. Let air run through your filtered solid for 5 to 10 minutes to dry it properly. For TLC testing, take some of your final product into a beaker and take some of your starting product, which is salicylic acid, into another beaker and dissolve them in acetone. Make sure to not add too much acetone so as not to have a too dilute of a solution. Then proceed to use a microcapillary tube to spot each of these compounds onto a TLC plate that you have marked beforehand. You may want to spot your compounds on your marks more than once if your solution is too dilute. Then place it into your solvent system, which is 1:1 ethyl acetate and hexane, and let it run. For ferric chloride test, take 3 test tubes and label them as control, salicylic acid, and aspirin. For aspirin 1, put some of your final product into the test tube. For salicylic acid 1, put some of the salicylic acid you used at the beginning into the test tube. And for control 1, do not put anything except for the solvent that you will use to dissolve these two solids. For the solvent, you will be using acetone. Since ferric chloride test gives a positive result in the presence of phenols, it would give a positive result in the presence of salicylic acid. If your product does not give any color, it means that you do not have any starting material in your product, which means you have synthesized aspirin by using all of your starting material. Upon the addition of a few drops of the ferric chloride solution in each test tube, you will see a color in the salicylic acid tube, no color in your product tube, and a similar no color in your control. You can see the salicylic acid containing tube turned pink, indicating the presence of phenols, whereas the tube that contains the product did not turn pink, indicating no presence of the starting material. Then proceed to take the melting point of your final product. For this, again use the larger capillary tubes with one end open and one end closed. Press the open end into your product and then pack it to the bottom of the test tube using the larger tube. Before performing any of these analysis tests, make sure to determine the weight of your product. Again, record the melting point of the product as a starting point and the end point where all of the product has melted. It will be a range and not a single melting point. You can go on to record the data from the TLC like we performed in the first TLC experiment under short UV light.